Hello everybody, I am Krishna Rao Patro. Today I will discuss about the OOPS concepts. Okay, so this is one of the basic requirement for any programmer in object-oriented programming. There are 6 important points you should note down in OOPS concept. One is abstraction, next encapsulation, next inheritance, next polymorphism, and classes and objects. Okay, first one is abstraction. Second one is encapsulation. Third one is inheritance. Fourth one is polymorphism. Fifth one is classes. Sixth one is object. So, if you want to know about OOPS concept, then you should know the 6 points. Then we will discuss one by one. First of all, you should know what is object-oriented programming. Object-oriented programming is a programming paradigm based upon the concept of objects. So, if you want to develop a program, you should follow one of the programming style or programming paradigm. Actually, there are different types of programming paradigms are there. Procedural paradigm and object-oriented paradigm as well as monolithic paradigm also. But one of the best design style or designing pattern, it is object-oriented programming. Which here in object-oriented programming, here completely concentrated on objects. Every object is having a combination of 2 things, data as well as the code. The object contains both the things, data as well as the code which is going to process on the data. The data in terms of fields and the code in terms of procedures. So when I say object, you should think only these 2 things. What are the attributes are there and what are the methods are there. So your complete program relies on objects. A common feature of object is that methods are attached to them and can access and modify the object field. Okay, object-oriented programming is a core of Java programming which is used for designing a program using classes and objects. So when you try to start your program using object-oriented approach, then first thing you have to start with the class and then you have to create object. Once objects are ready, then you can do processing. The object-oriented programming is basically a computer program design philosophy or methodology that organize or model the software design around the data and object rather than functions and logic. So it is trying to keep concentrate towards data part. So how I can organize the data? Once I concentrate on the data, then I can do processing on the data. So your object in programming always gives more importance towards the data part. That's why it supports data abstraction. It supports data abstraction. Object-oriented program simplifies the software development and maintenance by providing major concepts such as abstraction, inheritance, polymorphism, and encapsulation. They are the core concept of OOPS. So please remember the 4 important core concepts: abstraction, inheritance, polymorphism, and encapsulation. Or you can say the pillars of OOPS: abstraction concept, encapsulation, inheritance, polymorphism. Now we'll discuss one by one. First we'll go for abstraction. Remember, when I say abstraction, it talks about the high level details. It talks about only high level details. The internal details we will not discuss. The abstraction is a fundamental concept of OOPS that allows to model the complex system in a simplified and organized manner. For example, if you think about the ATM, inside the ATM machine there are many things are there, but we are not discussing. So we are saying that how to use the ATM, how to insert a card and how to withdraw the money. So these are only high level details. What exactly you can do with ATM? So using ATM, what I can do? I can insert a card and I can get the money. So that is the main use of ATM. So abstraction talks about only high level details. Internally how ATM works we are not discussing. Internally what circuits are there, what are the different mechanisms they have installed internally, those things we are not discussing. Only discussing about what exactly we can do with ATM. These things we are discussing. So that is nothing but abstract. It involves focusing on essential feature of object-oriented system while hiding the irrelevant details. Those internal details not relevant to us. That is for the developer, the fellow who is designing. So for us, we have to think about high level details. The concept allows us to implement from the user but shows the only essential information to the user. So it talks about what to do but not how to do. Again here you should remember also, again abstractions are again mainly focusing on two things: procedural abstraction and data abstraction. Okay. In terms of OOPS, we'll say first data abstraction, then second procedural abstraction. So our Java completely concentrated towards data abstraction. Whereas when you come to your C or Pascal, that comes towards procedural abstraction. Okay. It enables us to represent the real world object or system as a classes, define their properties and behaviors, and while hiding the internal details. That is the main goal of abstraction. Abstraction involves creating abstract class or interface that define a blueprint for other classes to inherit from. So you have to design high level details. So generally abstraction useful for the design stage. Useful for the design stage. These abstract entities cannot be instantiated directly but serves as a foundation for creating concrete classes that implement their methods and properties. So generally abstraction will be decided at the beginning level itself. What to do? Those things will be specified in the abstract layer. The main goal of abstraction is to provide simplified and well-defined interface and interacting with the object, shielding the user from unnecessary complexity. So unnecessary complexity will be removed at the abstract concept. So abstraction will give you only high level details. It allows the programmer to focus on high level concepts, modularize the code, enhance the maintainability, reusability, and overall code quality. This is the actual main advantage of abstraction. So you can say it reduces the complexity, it focuses on high level concepts, enhance the maintainability, enhance the reusability, and overall code quality will be improving. These are the main advantage of abstraction. Then we'll go to the next concept. How you can implement this abstraction. Now this is my one abstract concept. Assume there is a car. In car what you can do? You can accelerate the car, you can slow down the car. This is one abstract representation of car. How accelerator works we are not dealing, and how you are slowing down we are not dealing. Only we are saying what are the facilities should be there in the car. So this representation is called abstract representation. When you combine the data and method together, that is called abstract data. So this is one type of data abstraction. This is one type of data abstraction. Similarly, I am having a machine. That machine helps me to stop the car as well as start the car. So this is also one abstract representation. Abstract representation. But how it is stopping and how it is starting the engine or machine, we are not talking. Only high level information. Whenever you want to go for implementation, then you have to implement in a class. For example, Audi car. I want to implement the Audi car system. So there I will implement both acceleration as well as slow down, as well as start, as well as down. So this is also one more abstract level of Audi car. So when you are writing the program, first you will write the abstract information. So the designer level, that means the project leader stage, they will be giving only these diagrams. This diagrammatic representation talks about only what to do. This what to do is called what? Abstraction. Okay. Then we'll go for one more important concept called encapsulation. Encapsulation is also one of the important features of OOPS. It is a mechanism which allows us to hold or bind the data and functions together into an entity. So when you are keeping both method and data attributes together, that is called encapsulation mechanism. So in a class, you will have a set of variables as well as set of methods. You have to keep together. When you are keeping together, that mechanism is called encapsulation. Or when you are writing the class, you are writing first data member as well as the method. So when you are writing both together as a single place, that concept is called encapsulation concept. So it protects the data and functions from outside interference or misuse. Therefore, it provides security for your application. The practice of keeping fields in a private within a class as a private and then providing access to those fields via public methods. So you can keep some data in the private part, but there is a mechanism to access it. So public security gives you to access the private data. Encapsulation is a protective barrier that keeps data and code safer within the class. So within the class, I can decide which is private and which is protected and which is public. So encapsulation is a mechanism which keeps data and method together with security. You can provide different types of security for your data. Public security, private security, as well as protected security. We can use those reuse object code like components or variables with allowing open access to data system world. So as a designer or as a developer, you should know which part of your program should be accessible to all, should be protected, should be fully private. Those things we will discuss under the encapsulation concepts. So you can have also comparison between abstraction and encapsulation. Abstraction also hides the internal detail. Encapsulation, it hides as well as it gives protection also. Whenever necessary, you can get outside. Abstraction solves the problem in the design level. Encapsulation solves the problem in the implementation level. So whenever you are implementing, then you will think about encapsulation. Whenever you are designing, that time you will think about abstraction. Abstraction is used to hide the unwanted data and giving relevant data. So during abstraction level, you will think about whatever the things you have to highlight. Those things only we will discuss. Encapsulation means which hides the code and the data into a single unit and protect the data from the outside world. So fully in terms of the language point of view, we'll think about the encapsulation. In terms of the design point of view, we'll think about abstraction. Abstraction let you focus on what the object does instead of how it does. So it will be talking about only what exactly the system has to do. That will be represented through abstraction concept. Encapsulation means which hides the internal details and mechanism how an object does something. So what are the mechanisms are there? What data to be accessed outside? What data should be fully protected? What data should be fully private? Those things we'll discuss here. Next, the fourth one, outer layout used in terms of design. The abstraction is a outer layout. That means the beginning stage, which is used in terms of design. For example, the outer look of a mobile phone, like it has a display screen and keyboard buttons and dial number. So when you are seeing a mobile phone, you are seeing about the outer layout and you are seeing a keypad and what are the numbers, those things you are seeing. But how internally they have implemented, those things we are not discussing. How my mobile number should be there. This is my mobile number. This is my keypad. What are the keyboards? Those things I will discuss. Only high level information about the smartphones we are discussing. When you go for encapsulation, you can talk about the inner layout used in terms of implementation. How the inner layout is designed. Those things we will be discussing about the encapsulation. Inner layout of the details of mobile phone. How keypad buttons and display screens are connected each other with the circuits. So some point we'll discuss at the high level, some point we'll discuss at the inner layer. So high level is discussed in the abstraction concept and inner level discussed at the encapsulation level. So encapsulation is implemented using access modifiers which control the visibility of variables and methods within the class. There are three access modifiers used. There are three different types of keywords are there which is used in Java. One is public keyword, private keyword and protected keyword. These are the three important keywords are there in Java to protect the data from outsiders. Public variables and methods can be accessed from anywhere, including the outside class. Public variables or public methods can be accessed outside. Private variables and methods can be accessed within the class and there whatever defined. So if you want to have full protection, go for private. If you want to have a full access outside, go for public. Similarly, protected variables and methods can be accessed within the same class as well as in the subclasses, or you can say derived classes. Okay. So what type of accessing mechanism you want to provide? Those things generally we'll discuss at the encapsulation level. So encapsulation enables the developer to write cleaner and more organized and more secured code. So the security concept generally we'll discuss at the encapsulation level. Now we'll come to one more important concept, because I told you 4 pillars: abstraction, encapsulation, and then inheritance. This is also one of the important concepts of OOPS. Inheritance is an important pillar of OOPS. It is a mechanism in Java by which one class is allowed to inherit the feature of another class. So this talks about the reusability. How you can reuse the code, how you can extend, how you can reutilize. Those things comes under the inheritance concept. So in Java, inheritance means creating a new class based on the existing ones. From the existing one you can inherit, you can extend it, you can extend. So that talks about what? How you can reuse the existing process or existing resource. A class that inherit from another class can reuse the methods and fields of the class. In addition, you can add new fields and methods to your current class as well as. So existing class I can reuse, I can extend it. That is the nature of inheritance concept. Then why do you need inheritance in Java? One for code reusability, another for method overriding. So inheritance concepts are used for these two purposes: to reuse the code, to override the code. Sometimes I want to only reuse, go for code reusability. Sometimes I want to extend, I want to modify, I want to update, then go for method overriding. So these two are the main features of inheritance concepts. The code written in the superclass are common to all subclasses. The child class can directly use the methods of parent class, simply using. I am not at all modifying. Similarly, method overriding. Method overriding is a special concept which is achievable through the inheritance concept. It is one of the way by which Java achieves through runtime polymorphism. You can override a method. So the parent method may have some statement. In derived method, you can modify, you can extend, you can change. That is the facility of method overriding. So method overriding also possible through inheritance. Without inheritance, overriding is not possible. Again, there are different types of inheritance: single inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So my Java supports these 4 types of inheritance. Java supports 4 types of inheritance. So you can see what are the different types of inheritance available. Assume A is the parent class, B the child class. So from A, B gets the information or B gets the resource. So here A is parent and B is child. So child gets the property from parent. So now this type of inheritance is called single level inheritance. Similarly, there is one more inheritance, multiple inheritance. A is one parent, B is another parent. C is getting the property from A as well as C is getting from property from B also. So whenever you are having 2 parents, then that is multiple inheritance. So for C, A is one parent, B also parent. So that means C gets property from both the parent. Of course, Java will not support multiple inheritance directly. So you cannot implement this inheritance directly. Of course, there is an inherent mechanism using interface concept. But generally, directly you cannot implement. Through class, you cannot implement. So that's why we will not highlight this part in Java. So there is one more inheritance called multi-level inheritance. There will be more than one parent. 1, 2, 3. That means A is one grandparent, B is one parent, C child. So from A, B gets property. From B, C gets property. That means C's parent is B and B's parent is A. Whenever more than one level of hierarchy is there, that is called multi-level inheritance. So A is one class, B is one class, C is one class. But C's parent is B. B's parent is A. So whenever such type of hierarchy exists, that is called multi-level inheritance. Java support this. Java support this also. Similarly, there is something called hierarchical inheritance. Hierarchy means there will be a single parent but multiple child. From A, there is one child called B. From A, there is one child called C. From A, there is a child called D also. So that means from a single parent, multiple childs are there. Hierarchy. Of course, from B, there may be some more child also. From C, there may be some more child also. From D, there may be some more child also. The hierarchy may continue. So this type of representation is called hierarchical inheritance. Okay. Similarly, there is something called hybrid inheritance. A is one parent. From A, B and C are two child. From B and C, D came. So this is also one inheritance. Okay. So that means here if you observe here, top level is from one parent to child. That is hierarchical inheritance. From B and C, D comes. That means this is multiple inheritance. So in this diagram, you are observing two inheritance. Here hierarchy, here multiple. Here hierarchical inheritance, here multiple inheritance. Whenever we are having more than one level of, means more than one type of inheritance, then that inheritance is called hybrid inheritance. More than one type of inheritance, if you are having, then that is called hybrid inheritance. Then how you can implement this inheritance? For example, if you observe the diagram, class A is one class, class B extends A. That means this is another class. So A is one class, B is another class. So B extends from class A. So that means B gets property from A. So whenever this type of program is written, that means this program implementing which inheritance? Single level inheritance. Single level inheritance. SLI. Similarly, one more example. Class A, class B, class C. There are three classes. A is one class. There is another class B. But B extends from A. That means B's parent is A. That means B gets property from A. Similarly, C is another class but gets property from B. So that means C's parent is B. So this program is implementing which level of inheritance? Multi-level inheritance. MLI. MLI. Multi-level inheritance. So in multi-level inheritance, you will find at least three classes. At least three. You can have 4, 5, 6 also. There is no limit. So more than one level of inheritance is called multi-level inheritance. So this program implements MLI, multi-level inheritance concepts. Similarly, if you observe this program, class A, class B, class C, class D. Now, here A is the parent. From A, B came. B extends A. That means B come from A. Similarly, class C extends A. So C is another class but gets property from A. Similarly, another class D. D is another class but gets property from A. So that means what? From single parent, multiple childs are there. So this comes under your hierarchical inheritance. Hierarchical inheritance. So sometimes they will give a program. Then they will ask you which type of inheritance is implemented in this program. If this program is given, then you can say this program implements hierarchical inheritance. Next, hybrid inheritance. Assume this program, class A, class B, class C, class C. There are 4 classes. A is independent class, but B extends A. B extends A. That means B gets property from A. Similarly, class C extends B. Class C extends. So C came from B. That means B's parent is A, C's parent is B. Again, D extends B. D extends B. So here, if you observe here, this is one level, this is one. That is here single level, here again hierarchy. Single level inheritance is there, hierarchy is there. If you think about 1, 2, 3, multi-level. If you think about this is multi-level. If you think about it, there is hierarchy. So this program is having combination of more than one type of inheritance. So this program is implementing hybrid inheritance. What inheritance? Hybrid inheritance. So they will give a program and they will ask you to identify what type of inheritance is implemented in this program. Or sometimes they will give a problem, they will ask you to solve it. What kind of inheritance you need to solve this problem? So by seeing this one, you can choose or you can write the corresponding inheritance. So these are the different types of inheritance supported by Java. And remember, whenever you want to implement inheritance concept, you have to use a keyword called extends. B extends class A. That means B derived from A. Okay. Similarly, C extends class A. So this is a, of course, don't write the class keyword, just write extends A, because already you said that A is a class. This is a template way of writing. This is not following the Java syntax. The only how the program will look. And there is one more important pillar of OOPS, that is polymorphism. It is one of the important concept of OOPS. Polymorphism is a word which is a word which is a combination of 2 subwords. There are 2 words. Polymorphism derived from 2 Greek words. One is poly, second is morphs. Polymorphs. Poly means what? Many. Morphs means form. So polymorphism means many form. One name with many form. Similarly, one person can do 2 different tasks in 2 representation form. For example, a person, he may be act as a normal person in a society. When you go to same person, when he goes to playground, he may be a captain also. So, or same person, when you come to class, he may be a class representative. So one person act in 3 different forms. So that means the person having polymorphic behavior. So one name with many form is called polymorphism. So Java supports 2 types of polymorphism again. One is compile time polymorphism, second is runtime polymorphism. The compile time polymorphism is also known as static polymorphism, and runtime polymorphism is known as dynamic polymorphism. So either statically or dynamically you can implement polymorphism in Java. So Java supports 2 kinds of polymorphism. So one is compile time polymorphism, second is runtime polymorphism. Compile time polymorphism you can implement with method overloading, or you can implement through operator overloading also. Similarly, runtime polymorphism you can implement through method overriding. This is overloading, this is overriding. So these are the different kinds of polymorphism concepts are there in Java. Of course, in the future days, we will be implementing different programs also. How you can implement different kinds of polymorphism. A simple diagram. There is a class called text. This is a text class. And there are 3 methods. Fun with int a, fun int ab, fun carry. Name of the function is fun only. But in the first one, fun takes single integer. Second one takes integer a and integer b. Function name is fun only. Same fun, but takes different parameter. Same function name, but different parameters. So in a class, you are having the function 3 times. Same fun 3 times. Same fun 3 times. But here parameter is integer. Here parameter is int, comma int. Means 2 parameter. Here char. So whenever the same function is available 3 times or more than 1 time, that is called method overloading or function overloading. This function overloading comes under your static polymorphism. What polymorphism? Static polymorphism. So static polymorphism is also called compile time polymorphism, because during compilation time it will be knowing where exactly this code will execute. So the location of the code is known at compilation time itself. That's why it's called compile time polymorphism. Because fun with integer, it may be bound to one address called 100. Fun with integer comma integer, it is also function. This function is available at the address 200. Similarly, fun with character, it may be available at the 300 address of the RAM. So that means I know where exactly this code will execute, at which place. That is well known. So during compilation time, I know this code will execute. So this type of polymorphism is called what? Static polymorphism. So how we are implementing static polymorphism? Using function overloading. So function overloading helps you to implement static polymorphism. This is one sample example. There is another example. There is a class called base class and there is a class called derived class. That means it is a parent, it is child. And there is a function called fun int a and there is a function called fun int a. That means in parent as well as child, same function name, same parameter. Here function is what? Fun with two integer parameter. Here also fun with two integer parameter. So in parent as well as child, you are having same function name, same parameter. So whenever you are having same function name, same parameter, in parent as well as child, in parent as well as in child, then that is called function overriding. Function overriding. This function overriding comes under your dynamic polymorphism. Dynamic polymorphism. Because during runtime, I will be knowing whether I am calling this function or that function. So which address I will execute, that will be known during runtime. That's why it is called runtime polymorphism also. It is also called runtime polymorphism. Okay. So try to know there are the different varieties of polymorphism supported by Java. So tomorrow in the next session we will be applying this polymorphism concept through program. So till today we are listening about all the concepts. Then now you have seen this abstraction, encapsulation, inheritance, polymorphism. 4 important things, 4 pillars. In addition to this, there are 2 more important items. One is class concept, second is object concepts. Because there are 6 important things you should know in OOPS. First, class. A class is a blueprint from which objects are created. Class is a blueprint, or you can say class is a logical entity or a generalized entity. Class is a generalized entity. That means in a general you can say. That means physically you cannot see. It is a, or you can say logical. It is imagination. A class is a group of similar object. A class is a group of similar object which having same behavior, same type of attributes and behavior of same type. Then you can design a class for that. A class is declared only once. Class will be declared only once. Class does not allocate memory when it is created, because class is a logical item. Physically does not exist. That's why it will not allocate any memory. Class is declared using a keyword called class. So whenever you want to define a class, you have to use a keyword called class. Class employee. Automatically employee class will be defined. Next, there is only one way to define a class, using class keyword. So these are the important concept related to class. For every class, you can create object. So I said Class is a blueprint. That means class is a general entity. But for every class, you can create an instance. So I can say object is instance of the class. Instance means what? Xerox copy. So whatever the behavior or whatever the attributes are there in the class, same thing will be reflected in the object. It's the exact Xerox copy. Class is a Xerox copy of the class. Sorry, object is a Xerox copy of the class. Object is an instance of a class or Xerox copy of the class. Object is a real world entity such as chair, pen, table, laptop, etc. which you can see physically. So an object is a specific entity or real world entity. Whereas it is a generic entity, that is specific entity. Object is a physical entity, whereas your class is a logical entity. Physically, you can see. For example, it's a pen. Pen, I can see. Similarly, I can say chair or I can say table. Chair, I can physically can see. Table, I can see physically. But when I say furniture, furniture is a class. So, furniture only can imagine. That furniture may be a chair, that furniture may be a table, that furniture may be a cot. So, it can be anything. So, physically what you can see, that is your object. Object is created many times as per the requirement. Once the class is declared, once you think, then you can create that many objects. For example, I will say flower. Flower is a class. But when I say lotus, you can imagine, lotus means yes, this type. Similarly, lily or China rose or jasmine, they are all objects of flower. So flower is general. Flower is a general but generic entity. Whereas lotus or jasmine, they are all physically I can see, they are all objects of flower type. An object is created through new keyword. So you can write the syntax employee, because I said employee is the class. Employee OB is the object, new employee. So you can create an object of the class. Similarly, there are different ways to create object in Java using new keyword or new instance or a clone or deserialization. There are many ways are there to create objects. So Java supports various ways to create object. Or I will give an example. I said flower. Flower is a class, whereas lotus is object. Jasmine, that is also an object of what type? Flower type. Similarly, lily. So class is always a logical entity or imagination entity, whereas your object is physically you can observe, you can touch, you can hold those things, or you can use those things are objects. So this is the difference between class and object. Here also you can see a class is a person. So when I say class is a combination of both data member and methods. If you combine both, that become a class. A class is a combination of data member and methods. The data members are also known as attributes. The data member is also known as attributes, or also known as properties. Okay. For example, for a person, unique ID. For every person, there is a unique ID. For example, your Aadhaar ID is a unique ID, or PAN number is a unique number. Name, age, city, gender, they are all persons related items. So these are called data member of the person, or you call attributes of the person, or you can say properties of a person. Similarly, what the person can do, person can eat, person can study, person can sleep, person can play. They are the operations, or you can say methods, what the person is doing. They are called methods, or called actions, or called behavior. What exactly you are doing, what actions you are doing, or methods or functions. Function. So every class is a combination of data member and methods, or you can say attributes and methods, or you can say properties and behaviors, or combination. An example of person. He is a person you can now see. See, when I say only person, you cannot imagine who is the person. But when I show this picture, he is a person whose name is Johan, whose age is 35, whose city is Delhi, whose gender is male. So now, they are the value of the attributes. So, in object, there is a value for every attribute. In object, you will find value for every object. Value for every attributes. These attributes may change with the help of these methods or with the help of these functions. Similarly, she is also one more person. Name is Daisy, age is 20, city Pune, gender female. So, they are the values for this object. So, this is first object, this is second object. But this object is different from that object. But both objects having same attributes. Attributes means what? Name, age, city, gender. Name, city, gender. These are the attributes. So, whenever you are writing object-oriented program, first you have to define a class. Once class is defined, then you can create object. How many objects you can create? You can create any number of objects. There is no restriction. So, today you will learn about object-oriented concepts. Okay. So, in the future session, we will be trying to implement those concepts through program. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.